Okay, here we go again. This is the last bit of chapter 17, 17H, and I'll talk about that at the end of the lesson. So, selections with and without replacement. Well, we've already sort of covered bits of this, so I don't think there's too much new in this section. So let's have a look. I've got a box here, a bag with 5 red and 10 green counters. I'm going to choose 2 of them. What's the probability they're both the same? Well, it depends whether you're replacing them or not replacing them. So, I pull one out of the bag, and then I pull another one out, but do I put that first one back? And so that'll change the probability. So let's look at both of those things. Sometimes it's not clear, they should make it clear whether it's with replacement or without replacement. So with replacement, I pick one and then I put it back in, so therefore the probability is not changed. The probability I get a red one is 5/15, 15 altogether, 5/15 red, 10/15 green. I probably should have just cancelled that down to to 1/3 and 2/3, but I didn't. And then the same again, 5/15 and 10/15 here, because once I replace it, there's 15 back there, and so the probability of it happening again is the same. So red, and then red is 25 out of 225, 50 out of 225, 10 5s are 50 out of 225, and 10 10s are 100 out of 225. Every chance we're going to make a mistake with some of those bits there, and so just a quick check to make sure, and that's why, whether that denominator, it would have been easier if it had been 9, but, given that they're all got the same denominator, 25 plus 50 plus 50 plus 100, let's start at the bottom, 100, 150, 225, 225 over 225, that's the only possibilities. You're either getting red red or red green or green red or green green, there's nothing else. So therefore those probabilities have to add up to 1. What's probability both the same? Well, that's red red or it's green green, so it's 125 out of 225 or 5/9. Okay. Now without replacement, so the first bit hasn't changed. Alright, I've still got 5/15 chance of getting a red and 10/15 chance of getting a green. Okay. However, the second bit has most definitely changed. If I've chosen a red one with the first one, then there's only, instead of 5 red and 10 green, now there's only 4 red and 10 green left. So the probability of getting a red one my second time around is 4/14, the probability of getting a green one second time around is 10/14. Okay. If I choose a green one with the first one, then instead of 5 and 10, I've now got 5 and 9. So it's 5 out of 14 and 9 out of 14. Multiply them together. Red red is 20 over 210, red green is 50 over 210, green red is 50 over 210, and green green is 90 over 210. Let's add them up again. 20, that's 70, 120, and 90 is 210 out of 210. Good. What's the problem? They're both the same. Both the same is red red or green green. 110 out of 210, so 11 out of 21. Alright, let's do one question from 17H. 17H, which one shall we do? Well, I guess we do the last one, number 6. 17H, question 6. Okay. A bag contains the same number of red and yellow balls. And we don't know what that number is, so I guess we call it X. This is an interesting one. So, same number of red and yellow, so X red and X yellow. Alright. One ball is selected and replaced, another ball is selected, so this is very much what we've just done with this one, except they made it tricky by not telling you how many. So the probability that the 2 balls are of different colours is a half. Alright, so this is with replacement to start with. The probability of getting a red or a yellow is X over 2X, which is a half, and a half here. And then if I'm replacing, then I'm getting a red or a yellow, a red or a yellow, and again it's a half and a half.
So the probability of getting red is a quarter, the probability of getting red, yellow is a quarter, half times a half, so half here. Yellow, red is a quarter, and yellow is a quarter. So the probability of different,
Gotcha. The probability of two balls of different colours.
probability of different equals this plus this. Y plus YR equals a quarter plus a quarter equals a half.
Well, no surprise there. But the second bit is a lot trickier. Two balls are selected without replacement. Find the smallest total number of balls, so the probability of selecting two balls of different colours is less than 0.53. Wow, alright.
Okay, R and yellow. I think we've still got a half and a half, but then it's absolutely changing for the next bit. The probability of getting a red one with the second one, given that so this is now without replacement. We've started with X and X, X red, X yellow. Red first, therefore we've got X minus 1 red and X yellow, and if we do a yellow first, then we're left with X red and X minus 1 yellows. So, the probability of getting a red one the second time around is X minus 1 over 2X minus 1. The total I've got here, I had 2X, one's gone, so now I've got 2X minus 1, and X minus 1 of those are red. To get a yellow second time around is X over 2X minus 1. It'll be quite similar on this one. If I've drawn a Y first, then probably I'll get a red is X over 2X minus 1. And the Y will be X minus 1 over 2X minus 1. Okay, so probability of getting a red is X minus 1 over 4X minus 2. A half comes out, so I just multiply the bottom one by 2. I've now got X over 4X minus 2. I've got X over 4X minus 2. And I've got X minus 1 over 4X minus 2.
As we've done with all of the rest,
The total probability should be 1. Well, they've all got the same denominator, so that makes it easy to add them. X minus 1 plus X plus X plus X minus 1 is 4X minus 2 over 4X minus 2. The total is 1. Okay.
Hasn't answered the question yet. Find the smallest total number of balls so that the probability of selecting two balls of different colours is less than 0.53. Alright. I'm going to let the probability of selecting two balls of different colours. This is it over here. Probability of different equals this plus this. That's red, yellow, and yellow, red. So it's 2x over 4x minus 2. Okay. If x is small, then this probability is larger. As the number of, as x gets bigger and bigger and bigger, if x was 100, I'd get 200 over 400 minus 2, so 200 over 398. It's getting closer and closer, but still greater than a half. But if x was, say, 5, I have 10 over 18, which is 5 ninths, which is a bit more than that. So we're going to get closer and closer to a half. Just graphically, on the question I'm asking, that there's 0.5, it's going to asymptote towards 0.5. The probability of getting two different. If x was, for example,
2 there. Well, if x was 1, if x was 1, there was one red and one yellow. I pick one and then pick the other one. Well, there's no choice, they've got to be different. And so if x was 1, I get 2 over 4 minus 2, 2 over 2, which was 1. So if x was 2, then the probability here would be 1.0, and then would move down. I want to find when that's equal to, probability equals 0.53. And presumably I'm not going to get a whole number for x, and so then the question is reading, looking at that, do I need to go to the next x or do I need to go to the one before? Well, let's find out. So I'm going to get 11 and a half. I don't know what we're going to be. So I want 2x over 4x minus 2 equals 0.53. Therefore, 2x equals 0.53 times 4x minus 2. 2x equals 2.12x minus 1.06, right? X equals 4 lots, yeah, that was right. That was 1.06 equals 0.12x, so x equals 1.06 over 0.12 equals, I don't think what I have got to find. I don't know what's happening. It's not working very well. Hopefully this one will work better. Okay. Hold on, 1.06. Find the smallest total number of balls so that the probability of selecting 2 balls of different colours is less than 0.53. Okay. So we're looking at that graph there. I want to be less than 0.53. Here's 0.53. And that happens at 8.33 when x equals 8.33. So for the probability to be less than 0.53, I need to go to the next one, therefore x equals 9. I guess we could, we could check that, try for x equals 8 and for x equals 9. So what I'm expecting is that for x equals 8, if I plug x equals 8 into here, I'm going to get an answer just a bit more than 0.53, and if x equals 9, I'm going to get an answer just a bit less than 0.53. So when x equals 8, 2x on 4x minus 2 equals 16 on 30. That is. Through when x equals 9, I've got 18 over 34. So the lowest value of x, that the probability, given the probability of being closer and closer to 0.5, the first value of x, where it's less than 0.53, is this one, which is x equals 9. Okay, so that completes chapter 17. There's lots of practice questions at the end of that, and then we move on to probability distributions. Sort of hard to know what's going to happen over the next couple of weeks or months. People are saying 6 months. Surely that's not going to be the
case, you know, I mean, a few weeks, maybe a month, maybe 2 months. But so, you know, I will put up videos for chapter 18, the probability distributions, at the start of next term, i.e. the 14th of Feb. That's when we're due back. Now, there's the likelihood is that we won't be back on the 14th of April. So I think that's a Tuesday straight after Easter. But that's, you know, I want you guys to be finished chapter 17, this stuff, by then. That's 2 weeks away, 2 weeks from tomorrow, I think. So that gives you some time to do that and to get that sorted. And then, you know, we'll put up lessons for chapter 18. Well, I really like probability distributions. It's, you know, it helps to explain a lot of things that happen around us, and, you know, why we get the probabilities we do, why things do happen. But you know, that's another bridge to cross. Meanwhile, you've got your IA. With the May session exams, as you're aware, the May session exams were cancelled, and so students' marks were based very largely on their IA. I'm assuming we'll still have November session exams. I mean, that's still 7 months away before the November exams start, end of October, I think they start. So 7 months away, surely, you know, a month or 2 to get through the worst of this, and then back to normal. However, what do I know? Not much. And so there's every chance that, you know, there is a chance that won't happen, that the November session exams will be cancelled, in which case your IA becomes particularly important, very important. So, over the next couple of weeks, over this, you know, holiday period, you need to make sure that IA is well underway. Right? Ideally, I see you in 2 weeks' time and we sit down and we look through it and we work out what else you need to do. Realistically, that's not going to happen. So you need to make sure that you have a topic, that you email me with that topic. We can, you know, and I'll say, yeah, I don't like that topic. What about something like this? Or, you know, how about, you know, I like that topic, and, you know, you could develop it by doing this or by doing that, or whatever. And then, you know, send me bits along the way. Right, this is the data that I've found. This is, you know what I've investigated so far. But I've run into a dead end. Yeah, so, you know, I mean, there will be difficulties with communicating, but hopefully, you know, not insurmountable. But, you know, you can spend this next 2 weeks, next 2 months, sitting around playing computer games, or you can be making really, really good progress, you know, with your IA and with this. So, you know, I mean, with the standard level maths, it's, as I've said a couple of times, it's not a big problem, because, you know, we'll finish the course comfortably, and it's just a question of how much revision we have. But ideally, we finish the course, you know, with plenty of time to do lots of revision. Okay, that's it. Any questions? Oh, no, yeah.